Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth. Today we talk with Dr. Rick Graves, an aerospace engineer who went from the open skies of Oklahoma to a digital world where aircraft are made up of zeros and ones.
In 3, 2, 1.
Welcome, Rick.
Thank you for having me here. I appreciate it.
You're our guest today because you do some really cool work with what you call Afrl's digital hangar. Could you explain what that is?
Right now, the Afrl has an initiative in digital engineering. We have a lot of really bright and talented people that are looking at kind of defining how AFRL is going to digitally transform to meet some of the design and challenges that we're seeing going forward with a lot of our aerospace systems.
So what exactly is digital engineering for a non-engineer?
Really, the official definition is it's basically an integrated digital approach where we use what we call authoritative truth sources for system data and models. So it's a continuum across a lot of the disciplines that we're interested in, like aerospace, aerodynamics, structural dynamics, propulsion systems, and it's really to look at the entire life cycle of an aerospace system, all the way from its early design phases all the way in until the system is disposed of. So it's the complete life cycle.
So like the digital part is, so you have a plane, like a fighter aircraft, but it's digitized so that you can run.
Right, we have a digital representation of a lot of the Air Force systems, and we are able to go in and do simulations based on those digital models. Now, this is something that we do because it's a lot cheaper for us to address problems or to look at physics-based questions through simulation. As you go up the scale to ground test and even a flight test, that becomes more and more expensive. So we like to give our decision makers the options to explore a lot of their concept development through digital means rather than going all the way to flight tests. So once you get up to a flight test, you know you're looking at something that has been through the ringer, so to speak. It's been vetted, but being able to look at preliminary concepts in terms of transitioning technology is something we really like to look at as early as we can.
To help us move faster, move
right,
smarter.
To help us transition our technology more efficiently.
And working with that then, so how much do you have built up in this digital hangar? Is this kind of a project you're going plane by plane or just a project by project?
This is something that's brand new. We hope to add to it as we look at new projects. So we're taking a few candidate test cases and we're maturing those to see how it looks and how it's received. And it's really not just a digital description of the model, it's all of the data that goes along with that model that might be useful in another concept called a digital thread that is another focus area for digital engineering.
And with the goal someday to be, like, let's say once you build this up enough, someone says, hey, I want a new part for, let's just say an F-22, you could just pull that up and start almost working on the plane itself, but in this digital hangar?
Well, it's all inside of our computers. If you have a new technology that's coming up, we would like to be able to look at that technology already modeled and integrated within our framework. This can be a existing platform or something that's brand new, that's say a new class of vehicle that's being designed. So you really want to look at how things are integrated together as early as possible in the acquisition process as you can.
That makes sense. And so you can do that before you go to a ground test, which is where you actually have something physical that you're testing, which would be a lot more expensive and timely.
Right. Especially for a flight test, because that's really, you start looking at does that vehicle that you've designed and you've taken through some ground testing, does that actually perform to meet the requirements? That's where you start also testing the human machine interface. Is this something that people are going to be comfortable flying? You look at a lot of our pilots that test these platforms. That's really a lot of times you wait until flight test to shake out some questions. So we would like to address these things earlier in the design process.
That's good, because some of our listeners might not be familiar with flight tests, so that's a lot more involved process.
Right. Oh yes.
And that's something that for the listeners as well to help kind of envision. So you said you have a lot of these stored in your database, but what does your day-to-day, you could say, look like? Are you working at a console? Is this like virtual reality? Like, how does this work?
I have a workstation at my desk, And a lot of the people on our applications team use a very similar workflow. So we have a digital model of an aircraft in front of us. We may be looking at high fidelity physics that are associated with the aerodynamics around that configuration, or we have other people that are more focused in structural analysis, as well as the interactions that go on between aerodynamics and structures, and that gets into a field called aeroelasticity.
That's crazy. Like, imagine that people don't really think about how many working parts go into an aircraft till you have to build one digitally.
That's right.
And a lot of these pieces then, so let's say you're running a stress test, so you'll do anything from inclement weather, different conditions, or is this just a very simple, you're showing what a standard takeoff would look like with these new parts?
Well, the Aerosciences Center that we're at within RQ is very much what I'll call a basic research to a more applied research organization.
Okay.
So we will have customers come in that are interested in exploring the aerodynamic, let's take a simple concept like aircraft drag. We may want to explore new types of technologies to reduce drag for our legacy fleet. So our basic research contributors will look at developing new techniques for things like flow control, as well as changes in the basic geometrical shapes that may influence drag reduction on something like a large transport, say like a C5. So the workflow workstations we have in front of us allow us to actually take the knowledge we learn from our people on our teams that are more focused in basic research, but we have to actually apply what they've learned in our models that we develop when we run our simulations.
So for those simulations, who are some of your customers or collaborators? It probably goes both ways.
We collaborate across the board with people from academia as well as industry, NASA. We will also communicate with the system program offices based on the project.
And kind of taking a step back from that, a lot of people may be wondering as well, how do you end up in a position like this? How did you become a digital engineer?
Digital engineering, again, is a relatively new term. I'm just a vanilla aerospace engineer, but I have a background in probabilistics. I also have an interest in things like data science and data engineering. So really, the future design of aerospace systems is couched in probabilistics. I'm looking at, to become if you're interested in digital engineering, what you're looking at is you're really overlaying a lot of new areas in the lab where you have to blend those things together. It's really a new type of career field for a lot of people. Like I have a son we hope he's going to be a Buckeye starting in the fall, and
nice.
he's very interested in anything digital. A lot of the new guys that come in, men and women that come into the lab, they're already well up to speed on a lot of the probabilistic techniques, which a lot of us have kind of tried to, had to kind of relearn as we've gotten into this field a little bit more. It's really an exciting area, I think, for people that are interested in maybe working for the lab is we are defining what the digital transformation for Afrl is going to look like in the next 10 years. So this is a time for new ideas and new approaches.
And what actually is probabilistics?
If you don't know what probabilities are, just think of people that go to Vegas. You start dealing with what's the probability of success for an aerospace system. So what's the probability that you may have a wing fail? You need to have methods that allow you to make those types of life cycle predictive outcomes before you actually test it. So you're looking at probabilities. It's really helpful to think of the probabilities you might see when you go to a place like Las Vegas. There's very fundamental classes in probabilistics that kids take these days in high school. Being able to apply that to an aerospace system requires some pretty structured approaches.
Sure, yeah, I was thinking, go back to my statistics classes, I just hadn't heard a phrase like
Yeah, I
that.
was wondering, but that makes a lot more sense.
Yeah.
So, and I'm assuming you have some pretty hefty equations then you got to pull out to make sure this works, or is this already pumped into the system?
You would like to take advantage of products which we buy from vendors that already have a lot of the probabilistic methods baked in.
Okay.
But it's all statistics derived. Anyone that's taken a statistics class, or there's a term that we call design of experiments. if you're going to do an experiment, there's a way to get maximum value from a minimum resource investment. And that really, there's different strategies for doing that. And I don't want to get too technical, but that's a common approach that we use in the Aerospace Systems Directorate.
And where did you take your studies? What college did you attend, or how did you
Well,
get on that path?
I grew up in Southwest Oklahoma. I was a Sooner through my master's degree. My classical training is actually more in the hypersonics realm, but I took a risk, quote unquote, and I went and I moved up to Colorado and got my PhD up at the University of Colorado up in Boulder. Taking a managed risk really paid off for me, because that's where I did meet my spouse as well. My son was born in the Denver area, and then we moved back to this area because Wright-Patterson was a nice halfway stopping point between Oklahoma and where my wife's parents are up in upstate New York. Wright-Patterson's a little bit weighted toward the Buffalo side of the United States, but both family sets are well within driving distance. So.
Did you always want to go into aerospace engineering?
Absolutely. I grew up on a horse ranch in Oklahoma with my dad. He's in the National Hall of Fame for paint horse racing. So I grew up with lots of horses around and lots of open skies.
Oh wow, do you still ride them?
Is riding allowed in Ohio? I'm not sure.
I've seen people do it, but you know.
No, I do know quite a few people that we work with that maintain their own horses at local stables and stuff. So, I mean, I grew up with that. I'll never forget it. I could smell horses on demand, so to speak. So, but we grew up under a lot of open skies, and there was always planes flying over where we were. The Air Force Base that's right near us, growing up in Oklahoma City, is up at Tinker. I still get questions as to why are you working at Wright-Patterson? Why don't you move back down to Oklahoma and work at Tinker? And I said, well, this is much more the area that I have a lot of interest in. Again, working in the lab is it's just a great place to work. I mean, I've worked in academia. I worked in industry for quite a few years at like a mid-level OEM. But being able to work in a lab environment, you feel like you're getting a return on your time investment. So it was natural for me to want to dip into aerospace engineering. But my dad served in the Air Force. He was in Korea, but he always wanted to be a pilot, but he was colorblind. So my goal growing up was to go into the academy. But then I found out I had congenital health reasons that I could not put on the uniform. So turned out I wasn't horrible at math and science. So I found out that was a way I could still pursue my interest in aerospace, was to just be an engineer. So, I mean, I knew from day one that that's what I wanted to do. I wanted to try to go through the Air Force and potentially get into the astronaut program. We have a lot of astronaut candidates in our area, as listeners of the podcast may remember. But
why do so many people from Ohio want to leave the planet? Sort of
leave
thing?
The planet.
Yeah.
Well, it's not just Ohio; it's from Oklahoma as well.
Oh, Oklahoma. Okay.
But if you've ever been in Oklahoma in mid-July, where you can get the entire month, there will be 100+ degree temperatures. I tell everyone I kind of grew up on the planet Vulcan, so they all get that if they've grown up in that area, because it's very flat. There's not a lot of mountainous terrain, so the droughts in the summer can be quite eye-watering, literally, especially if you have a lot of livestock and stuff that you have to take care of. So.
I bet. Yeah. Wow.
So that's where my interest area came from, and of course the wide open skies also fed into my. I have a twin brother. His interest is always in astrophysics. So while I was thinking about how I was going to build maybe the next spaceship, he was using telescopes, to look at the stars, which if you're out in the country and you're away from the city lights, you're able to get some really nice views of the solar system. Yeah. And just looking at stars and stuff was always something that we just grew up with. And you kind of take that for granted sometimes. And we always like to go back and visit when we can, just to remind myself of the things. I mean, there's definitely a reason I left the farm to pursue my own fortune. So my parents were very good at giving me reasons to develop a way I could sustain myself, literally. So
Yeah.
That's great, though.
I wasn't expecting to draw that parallel from growing up on essentially a horse farm to like that. That's why you wanted to be an aerospace engineer.
Sure.
But
Yeah, I mean, family dinners
Thanks,
have been
guys.
great too, because you
Oh,
guys
yeah.
have, you said he's more astrophysicist. Is he still working?
No. He went to school to try to learn to be an astrophysicist, but
Okay.
he found other stuff that he was interested in doing, and he's pursuing that instead.
gotcha.
But I know way too much about astrophysics, but you don't really get a chance to apply that in the laboratory too much. So
Yeah, with along those lines, then you mentioned beforehand that while you weren't able to go into the astronaut program, you still work with students who've run through the program or help other aspiring students here at the labs.
sure. In fact, we have a young lady coming in just next month through the Legacy program. So she's a high school student, and we're going to bring high school students in, as well as students just getting their bachelor's and their master's, as well as those that are pursuing their PhD. So we give them the ability to be kind of exposed to our modeling and simulation process. Anyone that leaves our organization will have hands-on experience with developing a lot of the data that's associated with the models that might go in our digital hangar. I also get an opportunity, which I really like, to actually work with a lot of the people who are in the military. I find that very rewarding. It's the closest thing I found to being able to put on the uniform. I'm in a position where I can have an influence on someone's knowledge base as well as their career, and that I know that when they leave our organization, they will have a very firm grasp of the types of things that we're trying to achieve in our mission, as well as you almost have the ability to, someone that's left the organization that goes to their next duty station will be able to reach back to AFRL if they need support in the areas that they know we support. So again, we're in aerospace systems development. I've seen similar relationships in other places like the materials directorate, out in Kirtland, as well as out at Edwards. The relationships you develop with the people when they come through they're lifetime relationships.
Yeah, the
and once
network
once they leave, they know they can call us, and a lot of times we're calling them to find out, what did you actually do when you produced this answer?
So when you mentioned the Legacy program, could you explain what that is exactly?
Well, I'm just learning about it myself, but the Legacy program is a way for AFRL to bring in high school students through a very specific set of competitive conditions. So we were passed a list of 8 to 10 candidates, and if their interest area matched up with what our subject matter expertise is, then we could put in a call and say we would like to lay hands on this person, and we think they can learn a lot and be very productive. Again, it's roughly an 8-week time frame for the turnaround of being able to start a project, work through it, and as well as finish and give develop a final project and a final report, give a final presentation. You would think that would be challenging, and it is, but I'm not surprised anymore about what young students can do. In fact, they raise the bar for us sometimes, and you realize, wow, if this guy with no training, or this lady with no training comes in and does this, I really need to up my game a little bit more, to double my productivity, so to speak. So
it's still pretty cool for a high school student. They're not that there's anything wrong with lifeguarding or babysitting over the summer, but to come in and work in a laboratory environment for the Air Force is pretty cool.
Well, the whole STEM concept, science, technology, engineering, and I apologize for missing the last M, but there's another component to that, and that's that my in-laws have told me about. It's A, and that's the artistic component. So turning STEM into STEAM is something that I'm interested in doing.
And is that something you implement in your teaching then when you bring in these? Is that something? Let me rephrase that. Were you always looking to help bring this message to people, like be a teacher, kind of showing what STEAM could do? I
have found myself in that role over the years. It's not necessarily something I've actively sought out, but that's turned into a fundamental component of the team lead role that I'm in, is that we need to be able to take people who maybe have no background in modeling and simulation and train them up quickly to be productive. So being able to do that, I've had my own mentors over the years that have showed me the value in doing that, and that the time that you spend helping someone get else up to speed is going to have a payoff down the road somewhere for you.
So do you have any advice to students out there looking to connect with the Air Force Research Laboratory?
Well, I mean, if there's any advice I can recommend to people who want to work the lab is come to the lab and be prepared to take risks. I've always been rewarded for taking risks, and you're going to make mistakes. Feel free to make mistakes and learn from those mistakes. One of my driving things that I try to do is I try to make plenty of mistakes every day, but I don't want to repeat the same mistake twice. So if you're not learning from the mistakes you're making, then that's on you. But making mistakes is definitely part of what I think of as the lab mentality. Again, we're looking at an area where we as scientists and engineers are trying to get the people who are accepting the technology we're developing to embrace more risk. Now, the people we're delivering the technology to, by definition, are risk adverse. So we're trying to get, there's always this constant tug of war between a lab environment where you have a lot of risk, and on the other side you have the people you're delivering the technology to that are risk adverse. So you want to get them much more comfortable with the risk that you're taking to deliver them the technology that they really want. So that requires a lot of communication between the two parties. There's also a paradigm that I like to follow I call it the SHIP principle. And SHIP stands for self-confidence, hard work, initiative, and positive attitude. And keeping the ship steady, so to speak, is what I try to do every day. So if I feel like I'm falling behind on something, or I want to know how to approach something, I try to do it with initiative. And things aren't always going to work out for you. Don't give up. If that's what you want, keep your eyes fixed on what your career goals are, and keep a positive attitude. And in my particular case, I was not able to join the Air Force or to go to the academy, but I am now in a position where I get to interact with people in uniform every day, and I found that was very rewarding. And I worked hard to get myself in an environment that I'm in today. And when a lot of people along the line may have said no, I didn't take no for an answer. I kept pushing at it. So know what you want and be willing to go after it.
Yeah, and is that something you've seen a lot then with the newer workers coming in, like not being as risk adverse that you mentioned?
Well, when new people come in, there's a little bit of trepidation that they're going to do something wrong or offend somebody. As long as you let people know what you're thinking about and what your technical opinion is, and you can back it up, people are going to accept new ideas. Now, sometimes you have to work hard to find the right venue for that new idea to take shape. And I'll use the digital hangar as an example. You can say that to some people and they'll be like, what is that? What are you talking about? But then other people immediately get it. And you have to be willing to explain basically the same concept to different levels of people with different technical backgrounds to be able to get across what the value is of what it is that you're working on.
Yeah, the whole point of what you've been telling us with this, the digital hangar, is for help people that are risk adverse, saying, hey, we're trying to cut down on larger risk tests. We can run here first. We're also looking at basically looking at new methods for exploring science and technology that is going to allow us to transition that in a much faster time frame than maybe what the lab is used to doing. So,
Rick, thanks for joining us today. I learned a lot about what is digital engineering, what do you do with our digital hangar, and you left us with a lot of great advice for future scientists and engineers. If you're listening and you want to know more about our scholarship opportunities and fellowship programs for anywhere from high school to graduate or even postdoctoral research, you can check out afresearchlab.com.
And remember, stay curious.
Logging off.